Hello and good morning dear students. So in today's class we'll start with question number 12. Okay, so let's read question number 12. In question number 12, the probability of event A occurring is 2 by 3 and the probability of B not occurring is 5 by 9. So I'll discuss with these two first. Okay, so I've written out here A and B are two events. According to the question, it's given to us probability of A occurring. So probability of happening of A is 2 by 3 and probability of not happening of B is 5 by 9. That's why I've mentioned out here B complement. So B means occurring, B complement means not occurring. A means occurring, A complement means not occurring. Okay. Also given to us, if the probability of getting success in at least one of the two events. See, A and B are two events. A and B are two events. If in the question it's given that if the probability of getting success in at least one of them, so at least one of them, either A or B. So A or B, probability of A means success or probability of B. Okay, I'm not telling both. So at least one. So probability of A or probability of B, that is probability of A union B is how much? 5 by 9. So sorry, 4 by 5. Okay, so this is the second line. If the probability of getting success in at least one of the two events is 4 by 5, so at least one of the two, either A or B, okay, is 4 by 5. Then the question is asking you to find what is the probability of getting success in both. So probability of A also and then B also, that is intersection we need to find. Alright, so intersection we need to find. Now, let's come to the point. I know P of A, I know P of B complement. So if I know P of B complement, then can I find P of B? We know, write down, we know P of B plus P of B complement is equals to 1 and P of B plus P of B complement means 5 by 9 is equals to 1. So therefore P of B will be 1 minus 5 by 9. So therefore P of B will be 4 by 9. Okay, so 4 by 9 I got the value for P of B. I know the value for P of A. I know the value for union. Therefore using probability of A union B is equals to P of A, that is 2 by 3 plus P of B, that is 4 by 9, and minus probability of A intersection B. Now what is the value for union? 4 by 5 is equals to 2 by 3 plus 4 by 9 minus P of A intersection B. So let's bring this A intersection B to the left hand side. It will be plus probability of A intersection B will be 2 by 3 plus 4 by 9 minus 4 by 5. Let us take the LCM. Please pause the video and note it down till here. Alright, I hope you have taken the LCM as well. The LCM you'll get is 45. So 3 into 15, 15 2s are 30, 9 5s are 5 4s are 20, 5 9s are 9 4s are 36. So therefore this is 50 minus 46, which is 14 by 45, which is the value for probability of E intersection B. So please pause the video and note it down properly. Okay. Alright, let's move on to the next question now. Now in this next question, given to us is there are 20 tickets which have been mixed up. There are 20 tickets numbered from 1, 2, 3 till 20. So 1, 2, 3 till 20. There are 20 tickets which have been mixed up. Okay, and now what we are doing is we are now drawing a ticket at random. So I'm taking out a ticket at random. The question is asking you, find the probability that the ticket drawn is a multiple of 3 or multiple of 7. Okay, what is the probability of getting a chance of ticket with number 3 or a multiple of 3, or a multiple of 7. So for that we have to define events. Okay, so are you understanding the point? Great. Let A be the event that ticket drawn is a multiple of 3, and then same thing with B. B the event that the ticket drawn is a multiple of 7. What is the question asking you? The question is asking you to find the probability find the probability that a ticket drawn is a multiple of 3 or 7. The question is asking you find the probability that a ticket drawn is a multiple of 3. 3 means A or 7 means this. We know the formula. Do we know the formula? Probability of A plus probability of B minus probability of A intersection B. We need to use this. We need to find as well as we need to use this. P of A, P of B, P of A intersection B. Now quickly let's find P of A. Now what is A? A is the event ticket drawn is a multiple of 3. Now from 1 to 20, how many numbers are there multiple of 3? Let's calculate 3, 6, 9, 12, 15 and 18. Okay, favorable chances of getting multiple of 3 is only this number. So 1, 2, 3, 4, 5, 6. So what will be P of A? P of A will be favorable chances divided by total, which is 20. So if I cancel this, 3 or 2 3s are 2 10s are. So the value for P of A is 3 by 10. Similarly, let's go with B. So B is an event that the multiple of 7. So multiple of 7 is 14, 7 and 14. Okay, 21 is greater, isn't it? So okay, so what is the probability of B then? Probability of B, how many chances? 2. 2 by 20, which is 1 by 10. Okay. And P of A intersection B, what do you think then? A intersection B, what do you think? Is there anything common? This is inside A, multiple of 3. This is inside B. Is there anything common? Is there anything common? No. So which means these two events are what kind of events? These two events A and B are mutually exclusive events. Am I clear with this? These two events are mutually exclusive events, and even they are not exhaustive events. Okay? They are only mutually exclusive events. What happens when mutually exclusive events? What happens? Therefore, the intersection is null. Probability is 0. 0 by 20, which is 0. Okay. So, therefore, I got all the values, isn't it? I've got all the values. What will I do now? We'll put this in equation number 1. Let's say equation number 1. Okay. Remember the values 3 by 10, 1 by 10. Okay. Can you clear this? Alright. So, therefore, from 1 I get this. What is the value for P of A? 3 by 10, 1 by 10 minus 0. So therefore this will be 4 by 10, which will be 2 by 5. Alright. So please pause the video and note it down properly. Alright. Let's move on to question number 14. In question number 14, see, whenever we are doing probability, then understanding of the question is very, very important. I said logic. In the first day also I said about logic, right? The logic has to be clear. I mean, what should you do? You should decide while reading the question itself. Okay, so please keep your mind, very alert and focus on your questions. Okay, please stay focused on your questions. Alright, so the question says, the probability that a student will pass the final examination in both English and Hindi is 0.5. So the situation out here is about the student. The probability that he or she will pass the final examination in both the subjects English and Hindi is how much? 0.5. The probability of neither passing is 0.1. Okay, so two conditions are there. So that's why I've made two events. Let A be the event that the student pass in Hindi, and let B be the event that student pass in English. Okay, given to us probability A intersection B. The student passed the final exam in both Hindi and English. So pass. Okay, so intersection is 0.5, which is the first thing given to us, and 0.1 is the value for the probability that neither he passes Hindi or neither he passes English. So if A is the event, that the student pass in Hindi, then A complement he does not pass. If B is the event pass in English, then B complement means that he or she does not pass in English. Okay, so intersection is 0.1. Remember that. Another thing given to us is, if the probability of passing in English is 0.75, if the probability of passing in English, so which is my event? English? B. If probability of B means what? That the student pass in English. If probability of him or her to pass in English is 0.75, then what is the probability that the student pass in Hindi? We need to find. Are we clear with the question? Once again I repeat, two subjects, Hindi and English. He passes in both. He or she does not passes in both. He or she passes in English. what is the probability pass in Hindi we need to find. Okay, intersection is there, PA is there, sorry, PB is there, PA we need to find. Yes, can I use the De Morgan's law out here? Okay, as probability of A intersection A complement intersection B complement is 0, 1. So therefore probability of this means A union B complement. I hope you have learned the De Morgan's law, and this means 1 minus probability of A union B means 0.1, and therefore probability of A union B will be 1 minus 0.1. So therefore probability of A union B will be 0.9. Am I clear with this? So I got the value for union, I know the value for intersection, I got the value for PB, therefore can I find P of A? Alright, from here only we'll find. We got the value for P of A union B. Let's use the formula, right? P of A plus P of B minus P of A intersection B is equals to 0.9 using the formula. PA I need to find, PB I know the value 0.75, right? P of A intersection B is 0.5 is equals to 0.9, so therefore PA 0.75 minus 0.5 will be 0.07. 0.70 means 7 only, right? No, wait. 2. Alright. 7, 5 and 0.5. 25, yes. This will be 5 and this. My mistake, 0.25, which is equals to 0.9. You can pause the video and note it down till here, and then we will do the next step. Alright, therefore P of A will be 0.9 minus 0.25. So if we subtract it, 0.9 minus 0.25, so since it is 0.9, you can write 0.90, you can borrow 1, 5, and then this is 6, so hence the answer is 0.65. so please note it down, pause the video and note it down. Alright, we move to the next question, that is question number 15. Now let's do it very quickly, I don't want to spend much of time. Okay, by the way, this is 2017 question. Okay, this is your IC 2017, an important type of question. Let's read the question quickly. In a class of 60 students, so there are 60 students in a class, 30 of them has opted for mathematics and 32 of them has opted for biology. Okay, in 60 students, 30 has opted for maths, 32 has opted for biology. Okay, 24 of them has opted for both maths and bio. So there are 60 students in a class. Out of 60 students, 30 of them has opted for maths. Out of 60, 32 has opted for bio, and there are 24 students who has opted for both these subjects. Okay. Now the situation is, if one of the students is selected at random, find the probability that the student has opted maths or biology. So out of 60 students now, some of them has opted for maths, some of them has opted for bio, some of them has opted for both. If I choose one student at random, what is the probability? Okay, what is the probability that the chosen student has opted for maths or bio? Okay, so in this type of questions, I need the help of the events. And here I have defined the events. Let A be the event that a student has opted for. Student has opted for maths, and let B be the event that a student has opted for biology. Okay, now a student is chosen at random. A student is chosen at random. Okay. Therefore, probability of getting a student who has taken maths is 30 by 60, because 30 of them have taken, so 1 by 2. Probability that the chosen student will be a student who has taken biology, how many of them are there? 32. So 32 by 60. So 4 8s are 32. 4 15s are 60. Okay. Both, right? Both. Probability that the student has chosen maths as well as biology, it is 24 by 60. So if I want, I can keep it as 60, 60, 60 also as decimal, as a denominator, okay? Because when I do the calculation, it will be very easy for me. So for the time being, I am not writing this. Because denominator is 60, it will be very easy for me to take the LCM. Okay, the question is asking me, the first question, what is the probability that this chosen student is a student who has taken maths or bio? Maths or bio. So formula is simple. Probability of A, probability of B, minus probability of A intersection B. Probability of A, 30 by 60. Probability of B, 32 by 60. Probability of A intersection B, 24 by 60. What is my LCM? 60. Are you clear now? The reason I've taken as LCM kept as 60. Okay. 30 plus 32, 62 minus 24. So 62 minus 24, this will be 8, and 5 minus 3, this will be how much? 5 minus 2 will be 38 by 60, so which will be 19, right? 19 by 30. 19 by 30. So please pause the video and note it down. Alright, then the next one is more important. Find the probability that the student has opted neither maths nor bio. So find the probability that this chosen student has opted neither maths. If he's taken maths, it is E. If he's not taken maths, A complement. If it's taken bio, B, not B complement. Okay, so we need to find probability that the chosen student has taken neither maths nor bio, means A complement intersection B complement. Maths also no, bio also no. Okay, so therefore De Morgan's law says that complement is equals to union complement, and this we know from the formula of probability of any event plus its complement is equals to 1. So this is equals to 1 minus E union B. Union B, we just formed it out, it was 19 by 30. So if you take the LCM 30 minus 19 is 11 by 30. Please pause the video and note it down. Alright, so now we need to do the third part of the question, and the third part of the question is find the probability that the selected student has opted maths but not biology. Okay, so we need to find probability that the chosen student has opted maths but not biology, means complement. Okay, so to understand this question more properly, what we'll do is we'll draw the Venn diagram. Okay, so Venn diagram means, see, there are two subjects, maths and biology. So I have kept as this as A, this is A, and this is B. So why I have made this kind of figure is because there is common, there is intersection. Alright, so this is E. So this portion of the student is E, and this is B. So what is A? A means the student which has opted for maths. Opted for maths is this much, and opted for biology is this section, and opted for both is this intersection. So this region are the students, that is 32 or 24. 24 student has opted for maths as well as biology. Okay, so as A and B, A is for maths and B is for biology. Okay, now if I only see for this much, then this is my what? Only the portion of the student who has taken for maths, and if I see only this section, this is portion of the student who has taken for biology. Now what is the question asking me? The question is asking me to find probability that the selected student is a student who has taken for maths and not for biology. So how will I do this? Okay, now as this is A, so from here to here it is A, I am standing a point, then where is my A complement? My A complement means this section. This section is my A complement, and this section is my B complement. Okay, so this is my A complement, sorry, this is my A complement, and this region is my B complement. Okay, please don't be confused. This whole is my A, this is my B, this is my A intersection B. So if this whole is my A, this whole region is my A, then what is my A complement? So this region is my A complement, and this region is my B complement. This question is asking us to find probability of A intersection B complement. Okay, so probability of A intersection B complement is going to be we need to find the common between A and B complement. Which is my A? This whole is my A. This whole region is my A. Okay? And which is my B complement? B complement is only this. So now what we need to do, we need to find a common portion. Common portion of A and common portion of B complement is actually this region. This dotted region. This probability we need to find. But how will I find? How will I find? I'll find this by using the formula. This is equals to, see, probably, how will I find this region? Area of this whole region and minus area of this shaded. So area of this whole region means probability, that is probability of A, and minus area of this shaded means, this shaded region means intersection, that is probability of A intersection B. Okay, so once again I'm making it clear with this. Make two circles. These two circles are for A and B. A is for maths, B is for biology. Alright, and then the intersection, this is the common portion, the student who has taken maths and biology, intersection. Alright, I also need the help of complement. So if this whole region is my A, then my A complement will be only this region, and if this whole region is my B, then this region will be my B complement. According to question, I need to find probability of A intersection B complement. Okay, so probability of A means this whole, and B complement means this region. So you just take the common part. What will be the common part? Common between this A and B complement. What is the common part? This B complement itself is the common part, isn't it? B complement itself is the common part. I understand my point now. This B complement itself is my common part. So which will be, actually I can also write this as probability of A, this whole region, minus probability of A intersection B. So let's put the value. Probability of A is how much? 30 by 60, and intersection is how much? 24 by 60. Okay, what is the LCM? 60, 30 minus 24 is 6. If we cancel it, then we get 1 by 10. Alright, so please pause the video and note it down properly. Alright, so we're in the last question for today. That is question number 16. Okay, so there are three persons, A, B and C are going for an interview. Okay, and the post is only one post. So if you read the question properly, for a post, for one post, A, B and C are going for an interview. Okay, the chances of being selected, probability of A being selected is twice of probability of B. Now B being selected is B being selected, the chances is thrice of probability of C. Now these are two things given to us. Okay, now the post has been filled. So find the probability of A being selected, B being selected and C being selected. That's the question. Okay, so once again, there are three people. They are sitting for an interview. They are facing an interview for a one post. Okay, the chances of A being selected for the post is twice that of B, and the chances of B being selected for the post is thrice of C. A, B and C. A chances twice of B, B chances twice of C. I understand my point? So the greater chances of being selected for the post is for A, and C is the least one. Okay, now suppose the post has been filled. The post has been now filled. So find what is the chances of A, what is the exact chances of B, what is the exact chances of C. We need to find. Are you clear with the question? So what kind of events do you think A, B and C are? A is a different person, B is another different person, and C is also different person. So first of all, they are what events? They are mutually exclusive events. They are mutually exclusive events. Are you understanding my point? And if you see them properly, okay, if you see them properly, A, B and C, if we add all the probabilities, if we add probability of A, probability of B and probability of C, then we get the sum as 1. Okay, so hence this is mutually exclusive and exhaustive events. So we can write down as A, B, C are mutually exclusive and exhaustive events. We can write probability of A plus probability of B plus probability of C is equals to 1. Probability of A being selected is twice of probability of B, and probability of B being selected is thrice of probability of C, and probability of C, keep it as it is. Probability of B is twice of probability of C, so you can write thrice into PC, so 3 into 2 is 6 PC plus 3 PC plus P into C, P of C, okay, so 6 plus 3, 9, 9 plus 1, 10, so 10, probability of C is equals to 1, so therefore probability of C being selected is 1 by 10, okay, and now we move to probability of B. Therefore probability of B being selected will be 3 into probability of C, which is 1 by 10, so therefore it will be 3 by 10. And then finally probability of A being selected is twice of probability of B, so probability of B is how much? 3 by 10, so 3 2s are 6, 6 by 10, that will be 3 by 5. So these are the answers. So please pause the video and note it down. Alright, so that's it for today, and then tomorrow is Saturday, right? So tomorrow will be your what? Tomorrow will be your open book exam number 4. Open book exam number 4 will be tomorrow. 4, right? Yes. Open book exam number 4 will be tomorrow. So please be prepared. With which chapters? With integration. We'll be prepared. We'll be preparing the open book exam for integration, till exercise, which exercise? Till integration by parts, okay? Till integration by parts. Okay, and today's assignment will be to do question number 17. So please do complete all the sums, complete number 17 and send it to me by tomorrow. And all the best for tomorrow as well. Take care and bye-bye.